Hello, on a Friday night I am going to go over two problems that I got questions on. This is a Webassign number 6 on the 2-2 homework, and the question is whether this particular identity is really an identity. Is this a true statement? So like the other ones we did in class, the first step is to change everything to cosines and sines, and I think I did this one in class, so maybe I need to clarify and do it much more slowly. So the secant squared is really cosine 1 over cosine squared. The cosecant squared is really 1 over sine squared. The secant squared is really 1 over cosine squared, and the cosecant squared is really 1 over sine squared. So I replaced all the secants and cosecants with sines and cosines. Now I'm just going to take that left part and combine the two fractions. So to combine fractions, I need to have a common denominator. And right over here, the cosine squared needs a sine squared with it to match both of these two denominators and make them equal. So I need to put a sine squared here on the bottom, and if I put it on bottom, I also have to put it on top. So here they are, bottom and top. Over here, the sine squared needs a cosine squared to make these two bottoms match. But whatever I do to bottom, I have to also do to top. So taking that and combining that gives me the sine squared over sine squared times cosine squared plus cosine squared over sine squared times cosine squared. Now I'm ready to combine the fractions. So the numerator now gets put together. I get now a sine squared plus cosine squared on top. And the bottom stays the same because that's what we do when we add fractions. The denominator stays the same. Now, sine squared plus cosine squared is the most famous identity. That's 1. So I can replace the numerator now with 1. So this left side that I have bracketed here turned out to become this yellow piece right here. But lo and behold, that yellow piece is exactly the same as my right side. My right side, if I put them together and multiply these two fractions, you multiply fractions by multiplying the numerators and multiplying the denominators. So to multiply the numerators, I get 1. Multiply the denominators, I get cosine squared times sine squared, which is exactly the same thing as sine squared times cosine squared. So these two things are equal. Because I have a match, it is indeed a true identity. I also had a question on number 5. Number 5 is a bit tricky. So they gave you cosine x, and they ask you whether it's any of these choices. Unfortunately, you have to take all of these choices now and break them down to sines and cosines, and that could take some time. Fortunately, there's not much work involved in every one of these choices. So let me start with the first choice. If I change the tangent to sines and cosines, which was the red list, and the secant x to 1 over cosine, which also came from the red list, then I get sine x over cosine x, which is the tangent, and that's all divided by 1 over cosine x. Now that looks pretty messy, but as we talked about in class, whenever I have a fraction over a fraction, no matter how disgusting it is, I just invert the denominator and multiply. So all I did now is I took this denominator over here, I inverted it, and now I'm multiplying. Those cosine squareds are diagonal across from each other, they cancel, and my final answer for this number 1, this first choice, is sine x. Well, now I look at the sine x, does it equal cosine x? That's not true, so it cannot be the first choice. So I X out the first choice. Now I go to the second choice, and I have to do the same thing. I have to switch the cotangent x to a sine and cosine, and the cosecant has to be switched to sines and cosines. By the red list, cotangent is cosine x over sine x. Cosecant x is 1 over sine x. I now have an ugly fraction over fraction, but I invert the denominator and multiply as before, and as before I see that the sine x's will cancel, which leaves me with cosine x's. Now that's good, because I see that those two things match. And because those two things match, I don't have to go on with my list. I know they already match, and therefore the second choice is the correct choice. And that's how you do that problem. So these were the only two questions I had, and I hope this helps, and feel free to ask me any more questions.